So in this video, we want to begin discussing discrete random variables. Well, first of all, a random variable is a measure of the outcome from a probability experiment, meaning we're looking at what are our possible outcomes within a probability experiment. Recall that probability experiments, all the probabilities must add up to 1. And so for the random variable, we denote that with the letter capital X. This just identifies this is my random variable. Well, most of the time what we want to look at first is discrete random variables. Recall that discrete variables are those that have a definite value. Most of the time they are whole numbers, but they have something that's definite. We know what it is, and it can't be anything in between those two numbers, such as number of people. I can't have half a person. Or the number of trees. Well, that's still, I can't have half a tree whenever I'm planting them and everything. Another example is the number of people who ate pizza. We're still talking about the number of people, so they're discrete. So you can have 0, 1, 2, 3, 4, and so forth. A continuous random variable, recall that continuous variables are infinite, meaning that they can be anything in between there, and so we're not exactly sure that it is exactly one item or another, such as the weight of a coin. Well, the weight of a coin can be 0.01, 0.2, 0.5, 1, 1.1, 1.2, so forth. The speed of a car is actually a continuous variable because it depends on the measuring device, how accurate it is. We don't automatically jump from 35 miles per hour to 36 miles per hour. We could be going somewhere in between. Most of our devices just do not measure it. So let's look at some examples and determine whether the random variables are discrete or continuous. Well, the number of cheeseburgers at a fast food restaurant serves each day. So this is how many are served. Well, think about it. Can a fast food restaurant serve half of a hamburger or a fourth of a hamburger? They can serve a fourth of a pound of a cheeseburger, but the number of cheeseburgers that they serve is actually whole, and we can count those. So this is going to be discrete. The weight of an automobile. Well, the weight of an automobile can be 1,400 tons or 1,400 pounds. It can be that, or it can even be 0.2 or 0.3. It can be anything in between. So that's going to be a continuous, because it depends on the measuring device how accurate that is going to be. The amount of rain in Seattle during April. Well, do we just say that Seattle got 4 inches? 3 inches? No, most of the time we actually say that they got 3.2 inches or 4.5 inches. So this one is actually a continuous as well. Now then, the number of mathematics majors in your school. Well, think about who the mathematics majors are. They are people. So whenever we're talking about the number of mathematics majors, these are actually going to be people, things that we can count. So this will be a discrete random variable. Now when we're looking at random variables, we want to look at their probability distribution. Their probability distribution provides the possible values that the random variable x can take on, along with their probabilities. It can be done in a table, a graph, or a mathematical formula. The biggest thing to note is, first of all, the probabilities for a discrete probability distribution must add up to 1. Can't be 1.3 or it can't be 0.9. Recall that all the probabilities for a single event has to add up to 1. They also have to be between 0 and 1. So I can't have a negative and I can't have like a 1.5. So let's look at the probabilities distributions that we have here, and we want to determine, are these probability distributions or not? So if I look here, first thing I'm going to look at is their probabilities. I'm not worried about their x values, I'm worried about their probabilities. I do not see any negatives, which is good. I do not see anything over 1, which is good. Now what I have to do is I need to add each of these up and see if they add up to 1. Well, when we add those up, we actually get 0.97. So since the sum of the probabilities do not add up to 1, this is not a probability distribution. Now let's look at the second one. The x's are okay, those are fine. I'm looking at the probabilities, and I've got a negative value here. Since I have a negative on the probability, this is also not a probability distribution. Because of that, probability of 5 is equal to a negative 0.01. That negative throws it off. Now let's look at this last one. Looking at the probabilities, I do not see any negatives. I also do not see anything over 1. So then I need to add it up. So I need to get the sum of the probabilities. And in this particular case, it adds up to 1.00. So it adds up to 1. So yes, this one is a probability distribution. So recall that we need to follow these rules right here. All the probabilities have to add up to 1, and I cannot be negative or over 1 for the probability. The x values can be whatever we want them to be. We're talking about strictly the probabilities. Now let's look at an example here. The Baseball World Series is played by the winner of the National League and that of the American League. The first team to win 4 games wins the World Series. In other words, the series will consist of 4 to 7 games, depending on the individual victories. The data shown consists of 40 World Series events, the number of games played in each series represented by the variable x. So this right here is looking at, okay, somebody won the game and won the series in 4 games. Somebody won it in 5, 6, or 7. Here are the number of series that played 4 games. So 8 years we only played 4 games in the World Series. 7 years, only 5 games were played. 9 years, 6 games were played. And 16 of the 40 years, we had to play all 7 games. So we want the probability of x, the probability that only 4 games were played. Well, think about probability as also being your relative frequency. Recall that relative frequency was your frequency divided by your total number. So I'm going to take the frequency, the 8, and I'm going to divide it by the 40, because we had 40 games. That's going to give me a 0.20. So 20% of the time is what we're looking at. Did we play 4 games? Now for the probability of 5 games being played, I'm going to take 7 and divide by 40. And I'm going to get to 0.175. I'm going to continue this with 9 divided by 40. That's going to be 0.225. And then 16 divided by 40. That's going to be a 0.4. So whenever I'm looking at these, the probability that we played 4 games in the series is 0.20. The probability that we had to play 5 games is 0.175. The probability that 6 games were played in the series is 0.225. And the probability that we had to play all 7 games is 0.4. I need to make sure, do these all add up to 1? So 0.2 times 0.2 plus 0.175 plus a 0.225 plus a 0.4 Yes, that equals 1. So I have all of my possibilities here. None of them are negative and none of them are greater than 1. So we've constructed a probability distribution. So I'd recommend that you go and practice creating these probability distributions and let me know if you have any questions.